Good evening, students. Today's session we are going to explore about the element of process dynamics interacting and non-interacting system. Okay, so coming to the element of process dynamics. Okay, so when you consider the process control, the hardware element, the important hardware element of first is a process. Okay, so you may, I hope you got some idea about what is a process. Process is nothing but the equipment which is going where the physical or chemical operation that is going to happen. Okay, so for example, if you take a liquid level control system, the process is a tank. If you take a thermal system, the process is a storage container. Okay, and next element is a sensor. Okay, and it's very clear that when you want to measure a particular parameter to model or control, you need to have a sensor. Okay, to measure the controlled output variable or a secondary output variable. Okay, so for example, if you take a thermocouple or resistance thermometer is used for measuring the temperature, or venturimeter for measuring the flow rate, or chromatograph for measuring the composition of the steam. And next is a transducer. It is always represented, the transducer is capable of converting one form of energy into another form, and it is always represented like if you take a thermocouple, it works on the principle of CPAC effect, where it is going to, when two dissimilar metals are connected together, there will be a hot junction and cold junction. There will be a temperature difference among these two dissimilar metals, which lead to a there will be a potential difference existing, which lead to a electrical voltage. Okay, so the purpose of transducer is converting one form of energy into another form of energy, and that particular signal, the signal from the field instrument, should be given to the control with the help of a transmission line. Transmission line is nothing but the cable which is going to carry the signals, electrical signal from the field to the control. Okay, and the next very important element, hardware element, is a controller, which is has its own intelligence. It receives the information from the measuring device and decides what action should be taken. Okay, so nowadays you can see there is digital controllers are available. The computers are going to act as a controller. Okay, and the next element is a final control element. We call that as a hardware element that implements the in a real life the decision taken by the controller. For example, the flow rate of the outlet stream should be increased in order to keep the liquid level in the tank. So we call the control valve as a final. And last is a recording element. These are used to provide the visual demonstration of the chemical process behavior. Usually the variables are recorded and the variables are directly measured as a part of the control system. The various type of recorders are available in the control room, that is going to display the visual display unit of the particular system. These are the hardware element of the particular system. Next, coming to the interacting and non-interacting system. Okay, if you see, there are two setup is available. The first one you call this as a non-interacting, and the second one you call this as a interacting. Why it is called as a non-interacting? If you see that the level in the first tank is going to study this dynamics in non-interacting, and we are going to consider the two tanks in which first one, the non-interacting, is connected in the fashion that such that the output of the first tank is going to affect the level in the second tank, and the output of second tank is no way going to affect the first tank. That's why it is called non-interacting. When you take the second one, the level in the first tank is going to affect the level in the second tank, as well as the level in the second tank is going to affect the level in the first tank. Okay, that's why it is called as a interacting setup. Okay, so coming to this, to explore this, let us explore the mathematical model of this interacting and non-interacting system. Okay, so first let us take a non-interacting system. We are going to assume there are two tanks. So obviously you will be having a two tank. The level in the first tank will be H1, level in the second tank will be H2. The inflow rate you represent for the input as a Qi, and the output of the first tank will be Q1, and the output of second tank will be Q2. The overall input is Qi, overall output is Q2, right? So when you take the overall, we have to determine the transfer function, that is H2 by Qi. Okay, H2 by Qi or Q2 by Qi. Okay, so to obtain this, let us say obtain the transfer function for each tank. Let us take a first one. The similar to, you will have two parameters. One is a capacitance 1 and the respective resistance 1, and second one is a capacitance 2 and the respective resistance R2, right? So when you take a first tank, the governing equation is C1 into dH1 by dt is equal to Qi minus Q1. And similarly, when you take a second equation, C2 into dH2 by dt is equal to Q1 minus Q2. Already we are there is a two control valves at the outlet of tank 1 and tank 2, and the respective resistances R1 and R2. So with that you can write that is represent Q1 as H1 by R1 and Q2 is equal to H2 by R2. Okay, so just try to simplify this equation. okay, and arrive the Laplace transform for the first tank and the second tank. So you can write the first tank, the Laplace transfer function is represented as q1 by q is equal to 1 by tau 1 s plus 1, where tau 1 is time constant of first tank, which is represented as r1 into c1, and similarly for the second tank it is represented as r2 by tau 2 s plus 1. Okay, so when you simplify this, you will get h2 by r2, which is nothing but q2 by qi. q2 by qi is equal to 1 by tau 1 s plus 1 into 1 by tau 2 s plus 1, which is nothing but the product of two first order transfer function, each with the transfer function of the single chunk operating independently. Now coming to the interacting system, the some way the dynamic of interacting system is somewhat different from the non-interacting case. When you take a first one, same the mass balance equation, sorry, the balance equation governing the particular tank. First one is C1 into dH1 by dt is equal to Qi minus Q1, and second one is C2 into dH2 by dt is equal to Q1 minus Q2, and in that way you represent Q1 is nothing but H1 minus H2 by R1, and similarly Q2 is represented as H2 by R2. You may explore this because this Q1 a wall R1, okay, the resistance R1 is connected between the level in chunk 1 and chunk 2. That's why it is represented as H1 minus H2, whereas R2 is connected only at the outlet of the second tank. Okay, so just try to simplify this equation by substituting the value of Q1 and Q2 in the respective tank 1 and tank 2 equation, and simplify this equation to arrive the transfer function. The overall transfer function of the particular setup is H2 by Q, which is R2 divided by tau 1 tau 2 s square plus tau 1 plus tau 2 into a1 into sorry, instead of a1 we represent as c1 into r2 into s plus 1. Okay, so the overall transfer function is represented like this. This is for a non-interacting. When you take a interacting, it is often referred to as a loading. The second tank is used to load the first tank. Okay, so in this way you represent the non-interacting modeling. Okay, so you can see that with interaction and without interaction. With interaction, you can see there is a additional parameter, that is R2 into C1. Okay, that is additional parameter which is involved. Thank you, students.